Let's practice some percents for our test. So I want you to write a percent as a decimal. Some of these are going to be crazy easy. For example, 96% is 0.96. It is that way because 96% is literally 96 over 100. And when you divide things by 100, you take the decimal and you move it once, twice, to where it would be right there. So 0.96. In fact, so we can kind of keep this rolling. 3% is 0.03 because that's 3 over 100. And you would move it 1, 2 times. And there would have to be a 0 there in order for that to work out. Now, I'm going to skip this one for now, the 5/8, just because it's not a decimal yet. And let's jump down here, 0.6 repeating. So here we had a percent written as a decimal, and we wrote it as a decimal. Now we're going the opposite direction. So up here, we moved it left 2 times. Here we're going to move it right 2 times. So it's essentially going to be this 0.6, this bar means it's like that, right? So we're going to move it 1, 2 times. 0.6 repeating is 66.6% repeating, like that. And 0.58 is just 58%. And now what we're going to do is visually model these, which is probably the easiest thing we do, but at the same time, it's just worth doing a little bit of practice with that. So when I say it's one of the easiest things we do, is really, I'm giving you a 10 by 10 grid. So watch 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? That's 100. So really, when it comes to drawing 96%, I just have to do every square except for 4 of them. So I gotta be careful. Done. So that is 96% because I did not do 4 of them. 100, minus 96 is 4. So those are the 4 I did not do. So all that redness right there, it would be 96% of that square. Now, I would love to ask you a question of like, if you had this much, what would be 96%? Or if I were to give you just a blank square and ask you to do that. I'd love to do that, but I'm not going to do that. Let's look at this one. This one is crazy easy as well because, oops, I thought it had the highlighter. Because 3% is just going to be 3 squares. That's it. 3% is very small. And now down here, 66%. Let's check this out. So we're going to do 10, 20, 30, 40, 50, 60, 1, 2, 3, 4, 5, 6. And then I'm going to go and do like a little bit more of the next one. Essentially, it's like it's 2/3 of that. And if you're like, what? Why is it 2/3? Because if we were to take 6 over 100, or really 66 over 100, if you were to divide that by 2, you would get 33/50ths, and on down the road, you would get down to 2/3. And if you're like, wait, 103, those don't go together, you're right. Really, I started with 66 over 100, but 6 over 10 would be even better, because when you divide both of those by 2, you get 3/5, and that's just 0.6. Either way, I'm trying to illustrate that, like, showing 6.6 repeating is actually not 66 over 100. It's not 6 over 10. It's actually 6. Here, hang on. Let me erase that real quick. It's actually 66 over 99 and 6 over 9. Now, that is a conversation for a totally different time, so let's move on. 58%. 5, 10, 15, 20. What am I talking about? That's 10, 20, 30, 40, 50, 51, 52, 53, 54, 55, 56, 57, 58. There's 58%. Now, what about these? Well, if you don't know it, you could try to multiply to make this thing be out of 100, but we're just not going to be able to make that work. Because no matter how many 8s you add to this, like no matter what you do to try and multiply to get this thing closer to 100, you're just not going to get there. Like if you multiply this by 12 over 12, you're going to get 60 over 96. You're just not going to get close to 100. Now, if you choose to give up and be like, okay, well, I'm just going to fill in 60. Okay, well, don't give up, dude, because here's what you're supposed to do. 5/8 is really 5 divided by 8, which means you can start to divide right away. How many times does 8 go into 50? 6. And if you're like, well, wait, isn't that 60 right there? It is, but check this out. Now, it's how many times does 8 go into 20, which is 2. That's 16. That's 4. How many times does 8 go into 40? 5. So this is 62.5%. So 10, 20, 30, 40, 50, 60, 62 and a half. So 5/8 of this 100 10 by 10 block ends up looking like this, okay? Where we had half of this square right here. Now, 4/5, I kind of did these in a little bit of an order, not to mess with you intentionally, but to show you like, okay, like, for example, this one was easier than this one, and this one is easier than this one, but the logic could still be used, right? So why is this one easier? Well, because this one, you can just multiply, and you get 80 over 100. So that means this is just 1, 2, 3, 4, 5, 6, 7, 8, done. It's 80%. But if you didn't know that and you were like, that dude told us to divide, I did. 4 divided by 5. 5 goes into 4 0 times. There's the decimal. 5 goes into 48 times. There's 0.8, which is 80%. In this next section, I'm going to review basically what we talked about when it came to LeBron James. I know that seemed kind of weird for me to mention, like, hey, let's talk about LeBron James. But the idea was that LeBron, seasoned basketball player, if you give him the ball, he could probably score effectively without any input from anybody else. So what am I saying? These problems and these problems over here, if you look at them and you're like, I can figure them out just by looking and doing some quick math in my head, then do it. But if you look at these and go, man, I'm not sure what to do, well, then that would be like LeBron saying, okay, I need my team's help. In fact, I need a team strategy. So some of the strategies we talked about were this. Is over of equals percent over 100. And if you're like, what the heck is over of? Right over here, it says, what percent of? So there's the of, right? Of 28 is. So here's what we're going to do. The what percent is the, I don't know what that is. What percent? I'm going to put that where the percent symbol was. That is going to be over 100 every time, okay? And then on the left side, what percent of 28? Of 28 goes where the of was. And then the last thing it says is 21. Is. So again, you might have looked at them and like, I know that answer. Cool. Maybe you didn't. If you did not, this is a possible strategy. So you cross multiply. That's something else that if you paid attention that we said, hey, this is how you do this. 21 times 100 is 2100. You can solve that by dividing both sides by 28. And 2100 divided by 28 can start dividing just like this. So how many times does 28 go into 21? None. But how many times does 28 go into 210? Let's see. Let's try 7. Let's try 6 to begin with. 6 times 8 is 48. 6 times 2 is 12, plus 4 is 16. We subtract here, right? So this is 10, and now this is 20, and we get 2 and 4. Okay, so I was too small. We need to try 7 instead. So let's get rid of that. And in fact, how did you know? Because 42 is what I got, and that's bigger than 28. So I can't be bigger than that number, because that means I did not do enough. So let's try 7. 7 times 8 is 56. 7 times 2 is 14, plus 5 is 9. There we go. So this is now 4, and 20 minus 19 is 1, and now 0 there. How many times does 28 go to 140? I think it's 5. 5 times 8 is 40. 5 times 2 is 10. 10 plus 4 is 14. Done. So our question was, what percent? And we just found out 75%. So I'm going to write that as a sentence. 75%. In fact, I'm basically going to rewrite this. Instead of saying what, I'm going to say I actually know. So here we go. 75% of 28 is 21. There we go. 64 is over of, remember, is over of. 64 is what percent? I don't know percent of 40. So we're going to cross multiply, and we get 40x equals 6,400. We're going to divide both sides by 40, and we are going to get that x equals whatever this ends up being, right? So one nice thing about this is when they both end in zeros, we can cancel out some zeros. So now it's 640 divided by 4, which looks like this. How many times does 4 go into 6? 1 time. How many times does 4 go into 24? 6 times. And we cannot forget this 0. So it's 160. Now this is where this is a little tricky. It said 64 is what percent of 40? 64 is 160% of 40. Because do you know what 100% of 40 is? Well, 100% of 40 is 40. So to be bigger than 40 means this has got to be bigger than 100%. What number is 80% of 45? What number is? I don't know what that number is, but it's the is over of. What number is 80% of 45? We're going to cross multiply, and we get 100x equals, now I don't know what 80 times 45 is, so I'm going to have to do that math, right? 5 times 0, 5 times 8 is 400. 4 times 80, well, you know what? I guess this is not that crazy. Hang on a second. I just did a little goofball error. So, by the way, there's a 0 here because when we're done with the ones place, now it's like we're multiplying 40 by 80. And that would be 3,200. So, 80 times 45 is 3,600. And now when we divide by 100, we just get 36. So 36 is 80% of 45. And that's something you could verify. And this is, like, you could have verified the other things, so I don't know why I'm going to stop and verify this one. But, for example, 80% of 45. If I want 80% of 45, you can find 10% of 45 by doing this. You take the decimal and move it once, 4.5. And then you multiply that by 8. 8 times 5 is 40. 8 times 4 is 32, plus that 4 is 36. We move one decimal. We move one decimal. 10%, so 80% of 45 is 36, and that's what we got here. Wowzers. 0.8% of what number? So here, I'm going to erase some of our work here so we can do some work here by LeBron James. Okay. So 0.8% of what number is 6? If you're not sure how I set that up, 0.8%, and then there's the 100, which was guaranteed, of what number is, okay? We cross multiply, we get 0.8x equals 600. We're going to divide by 0.8, which is 600 divided by 0.8. And we could already start dividing like that. And in fact, what do you mean by already start dividing? I learned a long time ago, when I was about your age, that if I write my division, if it starts like this, I can write it like this and then immediately begin dividing. And I don't mess up the order. And you might think, oh, that sounds pretty simple. I've probably said that 3 dozen times, and I still see students accidentally swap these two numbers. So maybe not as simple as I think or you think, I don't know. So we can't really start with 0.8. We're going to need to move the decimal. So we're going to move the decimal here. And now we no longer have 600, we have 6,000. So how many times is 8 go into 6,000? Well, 6 times 8 is 48. 6 times 7 is 50. 8 times 7 is 56. 8 times 5 is 40. And let's see, we took care of that 0, but we haven't taken care of this 0. So there it is. We just got 750. So 0.8% of 750 is 6. And in fact, that doesn't seem right. Remember how small 3% is? Well, 0.8% would be like if we only had this much of the square. That's 0.8%. It's not even a whole percent, right? So not even a whole percent of 750 is 6. Next, we have identify the percent of change. Percent of change as increase or decrease. How we did that is we said, let's take the new number minus the old number, and we will divide it by the old number. And if you're like, what does that mean? Well, it means you have to read. Ricky's first game had 4 strikeouts. His second game had 10. Well, sounds like his new game had 10. His old game had 4. So we will do 10 minus 4 divided by 4. And that is 6 over 4. And what we do at that point is if you know what percent this is, then you go for it. If you don't know what percent this is, you could reduce the fraction. And does that help you? And if it still doesn't help you, then divide. So 6 divided by 4 or 3 divided by 2, we're going to get the same thing. And here's how that looks. I'm just going to go and do both. 4 into 6 once. And there's going to be a decimal. Bring down a 0. 4 into 20 5 times. So maybe you saw that this was 1.5. Both of them are 1.5. So he had 150% increase in his strikeouts. When I left for my trip, I had $240. I had $240. After the first day, I had $180. So again, I'm thinking the new is $180, the old is $240 over $240. Some of y'all have broken down right here because you're like, let's see, $180 minus $240. How do I do that again? So why don't you do this? Hang on, let me erase that. Will the answer to this be positive or negative? It will be negative because 180 minus a bigger number will be negative. So if it's going to be negative, then why not solve it like this and go, okay, 24. I don't know why I just did that. Hang on, 20. So 1 and 14. This is 6. So it's 60. So we have a negative 60 over 240. Negative 60 divided by 240. We can put a 60 there. No need to make it negative here. We don't need to do that because we're just going to keep in mind that the answer is negative, okay? So 240 goes into 60? No, it doesn't. So we need a decimal. 240 goes into 600? Yes. How about, let's see, twice? 2 times 0 is 0. 2 times 4 is 8. 2 times 2 is 4. So when we subtract this, we get 120. And when we do, how many times 240 go into that? It is 5 times 5 times 0. 5 times 4 is 20. 5 times 2 is 10, plus that 2, 25. So it was a negative 25% change. So we could say this was a 25% decrease. Remember when I said if you could just look at this and tell what it is? I skipped that, didn't I? Because maybe you would have said, well, listen, I could divide both of those, get rid of both of those zeros, and now that's 6 over 24. And both of those could be divided by, let's say, 3. So that's 2 over 8. Wait a second, that could be divided by 2 and by 2. That's 1/4 or 25. So again, that's how you could do some of these if you don't remember how to do the division part. And now we're going to jump to the backside. Okay, back here, I say back here because it's on the back page. All of these problems are going to be some variation of multiplying to find a percent, adding because the price goes up, or subtracting because the price goes down. That's all you got to do. If there is any division, it's because you are splitting a percent. And if I'm splitting a percent, yeah, like if you went from 10% down to 5%, you would get there by doing 10% divided by 2. So this is one scenario. Another scenario is if instead of subtracting by half, if you were cutting a bill, if you're cutting the bill in half. Now, I don't remember that happening on here, but I'm giving you like an order of like how probable these things are. You're gonna be multiplying. You're gonna be adding and subtracting. You might be dividing. So let's do number 13. The original price of something is $15. There's a 5% discount. What's the sale price? So you have several approaches here. You could find 10% of 15 and then divide by 2. That's one approach. You could find 1% of 15 and then multiply that by 5. Let's see, what else? You could find You could just do 15, which is that price, times 0.05, because that's 5%. So there is going to be several ways to do these things. That's why we talked about LeBron over here. Is LeBron, when he looks at the rim, he's like, I could dunk it, I could lay it up, I could alley-oop, he's got all these ways, right? So let's go with 10%. 10% of 15 is 1.5. And if we divide that by 2, in order to get 5%, we would get 0.75. And in fact, how do you do that? Well, because 2 divided by 1.5 is 7.75. So you can kind of see how maybe that approach, not as good. Maybe we take 1%, which would be 0.15, because, right, 15, and you move the decimal twice. And if you're like, how do you get 1.5? That was just moving the decimal once, okay? So 0.15 times 5, well, that's 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. We moved the decimal twice. Look, 0.75, 0.75. Either way, you're taking 75 cents off of this. So the answer is $14.25. A store buys items in order to sell them. Duh. They buy sunscreen for $5.50. They then mark up the price by 75%. At what price do they sell them? So here's what we can do. We can find 10%, and we could multiply that by 7.5. That would give us 75%. We could just do 0.75 times $5.50. Let's see. What else? I'm trying to think of what else. Oh. Here's an unusual division one. We could do 550 divided by 4, because that gives us 25%. And then we'd multiply that by 3. I don't think you're going to do that, but you could. One reason why I don't think you want to do that is because 550 divided by 4, I don't see how that's going to be real clean. You know what I mean? I've been saying that 10% is your best friend for a long time. So I'm going to do 7.5 times 10%. And 10% is, that's not the wrong decimal right there. Take this decimal right here and move it left 1. That's how you find 10%. So times 0.55. So 5 times 5 is 25. 5 times 7 is 35. We're done with that 5, so we put a 0. 5 times 5 is 25. Oh, look, it's going to be the same thing. 5, 2, 1. It's now move 1, 2, 3. 3 places. 1, 2, 3. They are going to add $5.50 plus $4.12.5. So you are going to pay $9.62.5 for this sunscreen. I realize that you don't have to do 62.5 cents, but I went ahead and included it. So if your answer is 9.62, count it. If your answer is 9.63, count it. If your answer is 9.62.5, count it. If your answer is anything else, no. GameStop has a buy one game, get another game, 75% off sale. I bought Halo 1 for full price at $50. So I'm paying $50 for that game. The price tag for Halo 2 is $30. This one is $30, but I'm cutting off 75% of its price. So I'm only paying for this much. And I'm paying for all of this too, right? So here we go. Just like before, I could tell you the different ways we could do this, But we just did one with 75%. Let's do this one with 75%. And if you're like, wait, why would we do another one with 75? It's a different problem. This one was a markup. You had to add. This is a mark down, a discount. And it's a little more complicated because there's two things, right? So here's what I'm going to do. I'm going to take $3 because that is 10% of 30. And I'm going to multiply it by 7.5. And if you're like, why are we multiplying by 7.5 when it's 75%? 10 times 7.5 is 75, okay? So 3 times 5 is 15. 3 times 7 is 21, plus that 1 is 22. Move the decimal once, move the decimal once. 75% of 30 is $22.50. So what are we doing with that? We are subtracting it. So we are only going to pay $7.50 for this game, okay? And then we're going to add $50 because the other game costs $50, so it is $57.50. Well, looky here. It's a copy-paste error. I did not catch this. So you'll notice number 14 and number 16 are really, really similar. I guess there's two different types of sunscreen that are both $5.50, and they both get marked up. But this one only gets marked up 60%. So let's just do this. $5.50 times 6. Why $5.50? That's 10%. Why 6? Because 10 times 6 is 60. 6 times 5 is 30. Move the decimal one time. And wait a second, not $33. What's going on here? I did not move my decimal enough. I should have moved it to be 0.55, which means I would move it twice, which means I would move this twice. That's a great example of an honest mistake that hopefully you would catch yourself so that you're not adding $33 to a $5 item, and instead you're adding $3.30 so that this item now costs $8.80. I've saved $500 towards my new computer. Not just my new computer, my new computer. And it's kind of funny that my is right there, so my. All right, I've saved $500 towards my new computer. That is 40% of my goal. What's the dollar amount of my goal? So this is part over whole equals percent over 100. What's that? That's the same thing as is over of. It's just sometimes we can express it a little differently, right? And in fact, going back to all of our percent talks, percents are literally comparing part of something to the whole thing. A percent, let's say it's 33%, that is telling you that I have this much of a circle when the whole circle is this big, okay? So bye-bye circles, let's do this thing. I've saved part of my goal. I don't know what the whole goal is. I know that seems a little silly, but what if, grandma's like, he saved $500 so far. He said, that's 40% of my goal. And then she's telling her friends, and they're like, well, Barbara, that sounds great, but how much is his goal? And grandma's like, I don't know, but I can do this. And so here goes grandma. You cross multiply, and you get 50,000 equals 40x. We're going to divide both sides by 40. These zeros can cancel, and so now it's 5,000 divided by 4, which is 1. Sorry. 5 minus 4 is 1. Bring down this 0. 2. 2 times 4 is 8. We have another 2. 4 times 5 is 20. 0, and then this last 0 just kind of pops up. So my goal is to save $1,250 for a computer, and I've saved $500, which is 40%. My. 25 students went to Greenwood with Mr. Sterling. 16 brought cameras. What percent of students brought cameras? This is the part of the whole class that brought cameras. I don't know what percent brought cameras, but I know that 100% were accounted for. You cross multiply, you get 1,600 equals 25x. You divide both sides by 25. 1,600 divided by 25. 25 goes into 160 6 times. 6 times 5 is 30. 6 times 2 is 12. Plus 3 is 50. 25 goes into 100 4 times. So guess what? 64% of the people brought cameras. So that's it for our percent practice. If you got questions, if you are lost on something, you need to reach out ASAP. See ya.